Now we're going to look at another way a firm could price discriminate. So we're going to look at what's called bundling. So I have an example of bundling here where Microsoft is offering a bundle of different software together as Office 2013. So let's have a closer look. So we can see here we have the Home and Student version, which was $139.99. It had Word, Excel, PowerPoint, and OneNote. And you also had Home and Business, which had also Outlook. And then there's a professional version, which has Publisher and Access. If we look at the prices of these, so let's look at the Home and Student. The price is $139.99. What are the prices of the individual items? So if we look at Word, that's about $80. Excel, it's about $80. So as soon as you want both of these, you're paying more than you would for the complete Office package, the Home and Student version. So why would Microsoft do this? Why would it essentially have a discount when you buy the bundle with all the different pieces of software together? Well, one reason might be that it enables Microsoft to price discriminate. So it could be that people have different valuations for these different pieces of software, but together they have a very similar valuation for all of them. So it could be that when you add up the valuations for all these four things, although each one might be quite different between different consumers, maybe they have a similar willingness to pay for the overall package, the overall bundle. And therefore you can charge closer to what they're willing to pay by just using one price. So in order to analyze bundling, we're going to introduce some definitions first. Let's consider just the case where there are two goods. So we're looking at multi-product monopoly producing two goods, A and B. We have what's called pure bundling. So that's where buyers have a choice between a bundle of A and B or not buying anything. They can't buy A or B separately. But then we also have what's called mixed bundling, where a monopolist offers a bundle of A and B as well as A or B or both separately. So this is mixed bundling. So in the example of Microsoft Office, it's mixed bundling. You can buy the individual pieces of software, so you can buy Word on its own or Excel on its own, but you also have the option to buy the Office package. So let's look at an example to see why bundling might increase a monopolist's profits. So in the table, we have two types of consumers, type 1 and type 2. We have the two goods, A and B, and we have the consumer's willingness to pay for each of those goods. So consumer 1 is willing to pay more than consumer 2 for A, and consumer 1 is willing to pay less for good B than consumer 2. Together, they're willing to pay the same amount. So here we're assuming that we can just add up the willingness to pay for the two goods to get the total willingness to pay. This isn't always true. There might be some complementarity between the two goods or substitutability. So it could be that they're willing to pay more or less for the two goods together than the sum of the individual willingness to pay. But here we'll assume they're willing to pay the sum. So we're going to assume also a zero marginal cost and one consumer of each type, just to keep the calculations simple. So let's first of all think about the maximum profit the monopolist could get if they sold these two goods separately. So there are two candidates for the optimal price for each good. So let's look at A. The monopolist could sell the good at 900 or 300. We have to work out which gives the highest profit. And because this 900 is more than twice 300, it turns out they're going to want to price at 900. But let's do the calculations. If they sell separately at 900 each, then the profit is 900 plus 900, which is 1800. Whereas if they sell separately at 300 each, then they sell one unit of each good to both types, and the profit is 2 times 300 plus 2 times 300, which is 1200. So they get a higher profit from selling A to just type 1 and B to just type 2 at 900. Now what if the monopolist offers a bundle? What should they price it at? Well, they should price it at the willingness to pay of the two consumers, 1200. And the profit will be 1200 times 2. They're going to sell 2 of those bundles and they'll make a profit of 2400, which is much higher than 1800. So the monopolist does much better by bundling than selling the two goods separately. And the idea here is that although the two consumers are willing to pay quite different amounts for the individual goods, when you add up their willingness to pay, you see that they're actually identical in this case. And so the monopolist is able to charge exactly what they're both willing to pay with just one price. So they can offer a bundle for $1,200 and leave the consumers with no consumer surplus, sell 1 unit of each good to both of them, and therefore they're going to make a higher profit. So the idea here is that by bundling, the monopolist is effectively charging each consumer exactly what they're willing to pay for each of the two goods. So effectively, they're able to charge each consumer a different price for A and each consumer a different price for B. So the type 1 consumer, they're being charged $900 for A and $300 for B, and the type 2 consumer is being charged $300 for A and $900 for B. But they're both being charged $1,200 overall. So we can think of that $1,200 as being made up of different prices for each consumer, and that's why we can think of this as price discrimination. So just to summarize that, bundling may give a strictly higher profit than selling separately. It can act as a form of price discrimination because it enables the monopolist to effectively charge different prices to different consumers for a different product. So one feature of this example I should point out is that there's a negative correlation in the valuations for the two goods. Type 1 is willing to pay more for A, and type 2 is willing to pay more for B. So we just saw an example of profitable pure bundling. Can pure bundling be unprofitable? Well, we're going to look at an example where it is. So we're going to do the same exercise as in the last example. We have changed the numbers now. So the type 1 and 2 consumers are willing to pay the same amount for A, $900, and type 1 is willing to pay $100 for B, and type 2 is willing to pay $300. So altogether, these are what they're willing to pay for the bundle. So let's look at selling separately. What's the most profit they can get? So again, we have to look at what are the optimal prices. And if we look at these two goods, well, the best price for A is going to be $900. They've got the same willingness to pay for that good. What about B? Well, they could price at $100 or $300. Here, because 2 times 100, 200 is less than 300, it's going to be better to price at 300 and just sell to type 2. So the optimal prices are 900 and 300. And the profit is 2 times 900 plus 1 times 300, or 2100. Now, if the monopolist offers a bundle, what should they price it at? Well, they should price it either 1000 or 1200. 2 times 1000 is more than 1 times 1200, and so they should price the bundle at 1000. And the profit will be 2000. So the profit in this case from bundling is less than the profit from selling separately. So this is an example of unprofitable bundling. So why was bundling unprofitable here? Well, the consumers have a very similar willingness to pay, in fact identical in this example, for good A. And so the monopolist can already extract all the surplus from the two consumers and sell to both of them by pricing at 900. There's no benefit to having a bundle. In fact, here pure bundling leads to a lower profit. And that's because it forces them essentially to sell good B to both consumers in the bundle. Because the optimal price for the bundle here is 1000, they're selling A and B to both consumers. Whereas if they sold separately, they can price high at 300 to consumer 2 and not sell to consumer 1. The problem is that the valuation for A is more similar than the valuation for the bundle, so they're better off selling it separately. So the difference between the two examples is that in the first example there was a negative correlation between the willingness to pay for each good. Type 1 put a high value on one good, and type 2 put a high value on the other good. And so together their willingness to pay were quite similar. In this example, their total willingness to pay for the two goods is not more similar than their willingness to pay for the individual items. So pure bundling can be less profitable than selling separately. So in that first example, we had two goods and those goods were negatively correlated, but it doesn't have to be that they're negatively correlated. What we need is that the sum of the valuations of all the goods, the overall valuation for all the goods, is more similar between consumers than the evaluation of the individual components. So if you think of an example like TV subscriptions, they're made up of a number of channels. You can also think of things like Netflix. So they have all this content, which when you look at it, there are things that you really like, others really won't like, and vice versa. But when you add them all up, you've got a quite similar willingness to pay for all the content that you're getting. And therefore, the company can charge a price quite close to everyone's willingness to pay, because when you add up all the items, everything sort of averages out. You're willing to pay a very similar amount. So to see how that works, let's look at another example where now there's not negative correlation, but consumers have valuations which are independent. So in this example, there are 4 types of consumers, and the valuation for each good could be either 7 or 13, and it's random. So there's one consumer of each type. Their willingness to pay for good A is 7 or 13. You can see there's an equal proportion having 7 or 13, and the same for B. And then if we look at the total valuations, we add those up. These are in this column here. They're more similar than the individual valuations for the goods. So the difference between these are 6, but the difference between these, well, these are the same. So let's look at the optimal pricing. So again, we're going to assume a zero marginal cost. So what is the optimal price if they sell A separately? Well, they can either price it at 7 or 13. If they price it at 7, they'll sell 4 units of good A and get a profit of 4 times 7, which is 28. Whereas if they price it at 13, they'll sell 2 units and get a profit of 26. So the best option here is to price at 7 and sell 4 units of A. And the same is true for B. And the profit they'll get overall is 4 times 7 for A plus 4 times 7 for B, which is 56. Whereas if they sell separately, they have to again think about the price. It could be 14, 20 or 26, which gives the highest profit. Well, it's not 26, that gives a profit of just 26. If they price at 20, they're going to sell 3 of the bundles and get a profit of 3 times 20, which is 60. If they price at 14, they'll sell 4 of them and get a profit of 4 times 14, which is only 56. So the best thing to do is sell the bundle at 20. And the profit will be 3 times 20. So the profit from pure bundling is greater than from selling separately. So by bundling, they actually get to price the 2 goods at exactly what they're willing to pay for these 2 consumers in the middle here. They're pricing it at 20 and they're willing to pay exactly 20. They give up a little surplus for the top consumer. They give up a surplus of 6, and they don't sell to the bottom consumer. Whereas if they sell separately, then they're giving up consumer surplus to all these 3 types of consumers here, selling both goods to all the consumers. And this actually leads, in this case, to a lower profit, a profit of only 56. So it's because these numbers here are quite similar compared to these numbers over here. So if there are more than 2 types of consumers, then pure bundling can be strictly more profitable than selling separately, even if there is no correlation between the willingness to pay for each good. So in this example, the willingness to pay for each good was independent. So finally, let's look at mixed bundling. So we're just going to show how this works with an example. So we need more than 2 types of consumer for mixed bundling to be more profitable than selling separately or pure bundling. So in this example, we have 3 types of consumer. The good here is a concert ticket. The different types of consumer are classical, industrial, and eclectic. And we have 2 different concerts. We have a Mozart concert and a Rammstein concert. And the classical consumer only likes Mozart. They're not willing to pay anything for a Rammstein ticket. The industrial consumer likes Rammstein but is willing to pay nothing for Mozart. And the eclectic consumer is willing to pay something for both but less than the other consumers for the one they like. So let's look at the optimal pricing. So first of all, let's look at selling separately. If they sell separately, what should they price the Mozart ticket at? Well, they don't want to price it at 0, so it's either 30 or 50. So if they price at 30, they'll sell 2 of them, the profit will be 60. If they sell at 50, they'll sell 1 of them, profit will be 50. So the best thing to do is price that ticket at 30, and the same is true for Ramstein. So the optimal prices are 30 for each ticket. So selling separately, sell each ticket at 30. Profit is 2 times 30 plus 2 times 30. They sell 2 of each ticket and they make a profit of 120. What about if they use pure bundling? So what should they price the bundle at? Well, the options here are 50 or 60. If they price at 50, they sell 3, they get 3 times 50, which is 150. If the price is 60, they just sell 1 unit of the bundle and only get a profit of 60. If they sell the bundle of the 2 tickets at 50, then the profit will be 3 times 50 or 150. So in this case, pure bundling is better than selling separately. 150 is more than 120. What about mixed bundling? So mixed bundling is where now they're offering the bundle of the 2 tickets, but also the 2 tickets separately. So what should they price these at? Well, if they price the ticket for Mozart at 50 and the ticket for Ramstein at 50 and price the bundle at 60, then they'll sell the Mozart ticket to the classical consumer, the Ramstein ticket to the industrial consumer, and the bundle to the eclectic consumer. We'll check that after we've calculated the profit. So the profit from this strategy is 1 times 50, they sell 1 Mozart ticket, 1 times 50 for the Ramstein ticket, and then 1 times 60 for the bundle. So they get a profit of 160, which is higher than the profit from pure bundling and the profit from selling separately. So mixed bundling is better than pure bundling and selling separately. Now let's just check that when we price at these levels, they actually want to buy the tickets I've assumed they buy. So let's look at the classical consumer. If they buy the Mozart ticket at 50, they get a 0 consumer surplus. What consumer surplus do they get from the other options? Well, they are not willing to pay anything for the Ramstein ticket, so they'll get a negative surplus from buying that ticket at 50. And they're only willing to pay 50 for the 2 tickets together, so they get a negative surplus from buying the bundle at 60. There's a similar argument for the industrial consumer. What about the eclectic consumer? Well, if they buy Mozart, for example, at 50, they would get a negative surplus. They're only willing to pay 20. So indeed, the consumers are going to buy the options we want them to buy. One thing I should point out here is that with mixed bundling, you can always do just as well as you can by selling separately or pure bundling, because you can always price the bundle or the separate options so that no one will want to buy them. So you can always simulate selling separately or pure bundling by pricing options so they're very unattractive. So for example, if we wanted to simulate pure bundling here, they could price the individual tickets at £1 million, and then no one's going to want to buy those. They'll only look at the bundle. So why was mixed bundling strictly more profitable here? Well, it enabled the monopolists to charge exactly what the consumers were willing to pay. So the features of this example are that one consumer is willing to pay a lot for one of the goods, the other is willing to pay a lot for the other good, and then we have a consumer with an intermediate willingness to pay for both goods. So just to summarize, bundling can be a form of price discrimination. It can allow the monopolist to charge prices closer to what the consumer is willing to pay.